This is a video on graphing functions and particularly interpreting graphs of linear functions. Here's our first example. So a graph is already drawn for us and we're told that the diagram shows the graph of y equals f of x. You can even see in the diagram that there's an f of x written in next to the line to indicate that that is the name of that function. We want to use the graph to answer a number of questions. First, we want to find f of 1. Now, I don't have a function that I can substitute this 1 into, but in any case, I want to use the graph to answer the question. We know that the value in brackets here represents an x value. So what we'll do is we'll go to that value on the x-axis. Now I'll draw a line down through that number vertically, and you can see that it meets the graph of f of x at this point just here. So now what I'll do is I'll take my ruler and my pen and I'll draw a line from that point to the y-axis. And the number that I land at on the y-axis is my solution. And in this case, we landed at 2. That means f of 1 equals 2. Next, I want to find f of minus 2. Again, we know that the number in brackets after the f represents an x value, so I'll now go to minus 2 on the x-axis, and I'll draw a line down vertically through it until I hit the f of x line. This vertical line meets my graph at this point here, and now I'll draw a horizontal line through that point to see where it goes on the y-axis. Again, the value that I land on the y-axis is my solution, and this time it's minus 1. The next question says to find the value of x when f of x equals 3. We know that another name for f of x is y, so really it's saying find x when y equals 3. This means that I should go to 3 on the y-axis to begin with. Now I'll draw a line horizontally through this. I can see that it meets the line f of x at this point. So now I'll draw a line down from that point to see where I land on the x-axis. This time I can see that the line lands on 2 on the x-axis, and that's my solution, that's the value of x. So I should write my solution as x equals 2. Next, we want to find the value of x when f of x equals minus 1.5. Again, we know that f of x represents y, so we go to this value on the y-axis. So I go to minus 1.5 on the y-axis, and I draw a line horizontally through it until I meet f of x, which occurs at this point here. I draw my line to the x-axis and I read my result, and read it as accurately as you can. Make sure, obviously, to use a ruler when you're drawing all these lines on your diagram. My solution in this case is the value minus 2.5. So I should write my answer as x equals minus 2.5. One of the easiest questions to answer when interpreting any function is for what value of x is f of x equals to 0. We know that this refers to y equals to 0, and of course y equals to 0 is simply another name for the x-axis. So a question like this is really asking us, where does the line go through the x-axis? This is quite easy to identify in our diagram. I can see that it occurs at this point here. So my solution is just x equals minus 1. Another question that we might be asked is, what is the y-intercept of f of x? The y-intercept is just where the line passes through the y-axis. In this case, that occurs at this point just here, which is where y is equal to 1. So y equals to 1 is our solution. We're still looking at the same graph, and here's an extension question relating to it that ties in with the coordinate geometry of the line chapter. What is the equation of the line f of x? If you're particularly strong at the coordinate geometry of the line, you may even be able to do this in 2 different ways. Pause the video here for a moment and see if you can figure it out. One approach is that we can identify the slope and the y-intercept of the line and use them to make the equation in the form y equals mx plus c. We've already identified the y-intercept, which will be the value for c. This is 1. We don't yet know the slope of the line, that's m. One way I can find slope is by using rise over run. So I can take 2 points and draw the triangle that connects them. Here I've shaded in one of those triangles. Its rise is 1 and its run is 1. So the slope of rise over run is 1 over 1, which is 1. As we discussed a moment ago, c is also 1 because that's where the line goes through the y-axis. So our line can be written as y equals 1x plus 1, or if you prefer, f of x equals 1x plus 1. You could also decide to find the equation using the formula y minus y1 equals m times x minus x1. For this, you'll need a slope and a point. You can use any 2 points on your line to find the slope. The slope formula is y2 minus y1 over x2 minus x1, and if you fill this in correctly, you should get a result of 1. You can choose any point that you like on the line to find the equation. I'm going to use the point 2, 3. I should label this as x1, y1 before I fill it into the line formula. And when I fill this in, it should read y minus 3 equals 1 times x minus 2. I'll tidy this up to get it y is equal to, and it also tidies up to y equals 1x plus 1, or if you prefer, f of x equals 1x plus 1. Here's example 2. In this graph, we have 2 linear functions. And we're told that the diagram shows the graphs of f of x equals 3x minus 2 and g of x equals minus 2x plus 3. Now, I have intentionally not labelled the diagram yet to indicate which is f of x and which is g of x. So I'd like you to take a moment here to pause the video, have a look at the diagram, have a look at the functions and see, can you match them up? When you're matching the function to the diagram, it's a good idea to have a look at a number of features in the function and in the graph that it goes with. Notice in f of x, it ends in minus 2. What might this represent? This value represents the y-intercept. And we can see that only one of these lines goes through the y-axis at minus 2. So we have good reason to think that this line is the one representing f of x. Just before we definitely fill this in, let's have a look at the other number in this function, which is the 3. What does that 3 represent again? So the number in front of the x, the coefficient of x, represents the slope of the function, the slope of the line. In this case, the slope of the line is being given by a positive value. That's positive 3. And we can see that this line is in fact sloping up. So this is another clue that indicates that this line must be the line f of x. Is the other line definitely representing g of x? Well, let's just look at the same features and just double check. So again, the number at the end here is the y-intercept. So let's see, is this other line going through 3 on the y-axis? Yes, it is. And note that in its equation, the slope is a negative value. And we can also see that our line is sloping downwards. So again, I'm happy enough that this must be the line g of x. Okay, now for the actual question. So the question asks us to use our graph to find the value of x when f of x equals g of x. First of all, it's important here that we're being asked to use the graph. So we don't want to do any calculations. We want to just look at the diagram and use it to come to our decision. We want to find a value of x. So our answer is going to be x is equal to something. When f of x equals g of x, so that's the information they're giving us that they want us to use to get to our answer. So what do they actually mean when they say f of x equals to g of x? Well, what this really means is the point at which the 2 lines meet. So we go to our graph and we identify this point. So it's obviously this point just here. So what point is that? Well, that's the point 1, 1. So I just want the x value. So my answer is x equals 1. Okay, so here's a little bit of an extension if you want to push yourself. We used the graph to find this solution, but what if we didn't want to use the graph? What if we wanted to use our 2 functions here, f of x and g of x? How could we go about doing that? What calculation allows me to find the point where 2 lines intersect? And this is my extension question. I want to calculate the point of intersection. We do this by using simultaneous equations. I'll start by writing down my two equations. These were f of x and g of x. Now I'm going to call them both y, so y equals 3x minus 2 and y equals minus 2x plus 3. Pause the video here and see if you can solve the simultaneous equation to find the point of intersection. And you already know what to expect for your solution. It should match up with what we saw in the diagram. Okay, so I want to cancel out one of my variables. I'm going to choose y. So I'm going to multiply my second equation by minus 1. And that means I'm going to change all the signs in that equation. Then I'll put my two equations together. My y's will cancel out, giving me 0. 3x and 2x will make 5x. And minus 2 minus 3 will be minus 5. Now I can solve this equation to find x. So I can say minus 5x equals minus 5. And dividing by my minus 5, I get x equals 1 just as I expected. How could I get the y part of the point? Because I'm being asked for the full point of intersection in this case. Well, I can simply take the x and substitute it into either of the original lines. I'm going to put it into the first one. So I can work out that y equals 3 times 1 minus 2. So y is 1. Finally, I put the x and the y together to make the point of intersection. And this point is the point 1, 1, just as we identified from our graph earlier.